All right, 1999 AB1 FRQ, we're given a velocity of t times sine of t squared for t greater than or equal to 0. In which direction, up or down, is the particle moving at time t equals 1.5? It's going up or down because it's moving along the y-axis. So all we have to do is determine the sign of velocity at 1.5. We're given a velocity, so this is going to be 1.5 times sine of 1.5 squared, and we'll just type that into a calculator, and that equals 1.167, which is positive. So we're moving up, so particle moving up. Part B says find the acceleration at t equals 1.5. So acceleration is going to be equal to the derivative of velocity, and we're specifically looking for the acceleration at 1.5, which is going to be the derivative of velocity at 1.5. So in your calculator, you're going to hit math 8, and that's going to give you d dx of, and you can either have this typed in as your y1, or you can just type in x times sine of x squared, and then you'll do that at x equals 1.5. So that'll give us the derivative of our velocity function. Ends up being negative 2.049. And what are our units? It doesn't give us units, so we're just going to say units per second squared. Okay, so but what the question is asking is the velocity increasing at t equals 1.5, why or why not? And we're going to say velocity is decreasing because acceleration is negative. Okay, so now we're going to go backwards. We're looking for the position of the particle. Knowing that at time 0 we have a position of 3, what is the position at 2? So if we take an integral from 0 to 2 of v of t dt, that's going to give us our displacement from t equals 0 to t equals 2. So what we want is we want the position. So we're now going to add that starting position because we know that y of 0 equals 3. So our position after 0 seconds is 3. So we're going to do 3 plus the integral from 0 to 2. So this is where we were. This is how much we're displaced, and that's going to tell us where we are now, our new position. Okay. So this will give us our position at t equals 2. So what you need to do then is we need to do math 9, and then we're going to do our integral from 0 to 2 of our velocity function, which is t times sine t squared. So we're going to do t times sine, and you're going to do x in your calculator. X times sine x squared dx, and then you're going to add 3 to that. Okay, and that gives us a position of 3.827. So we say y of 2, the position after 2 seconds, is 3.827. And then now we're looking for the total distance traveled from t equals 0 to t equals 2. So for this one, we're going to integrate the absolute value of our velocity. And that's going to take our negative movement and flip it positive, so it just tells us overall how far we've gone. So same thing that you'll type into your calculator. You do integral from 0 to 2 of absolute value of x times sine x squared dx, and that's going to give us 1.173 units. All right, that's it. 1991 AB1 FRQ.